And I am live. That is nice. Today is 17th of October 2025, Friday, and something crazy happened yesterday or today, technically. Team Impala dropped his new album, Deadbeat, which is amazing. And with that introduction, let's begin. Mist. Yes, I am calling this project Mist, and I have made a GitHub repository for the same. Yep, Git repo. Here we have the client code and the server code. Yep. But yeah, this is different. This is not exactly the same code that we wrote yesterday. This one is like basic code, which we were supposed to write in this thing, right? Which they told us that we should write, in which the client and the server are just saying hello, hello. Yep, this is the basic code we have. And yeah, that is cool. We also have a README here. Yep. And with that, let's begin. Yep. Yesterday, more on socket API. So yes, here there are some important things which are not immediately relevant, but are going to be relevant in a while later on. And they are, yeah. So these things, like how these structures are, just things about them. And yep, this is called libraries, connect, bind, what these things actually do, right? And domain name resolution and stuff. And I guess because these things, these theory parts in this project thing are very concise. They are to the point, and they are more like a definition instead of like explaining these things to someone. So I would suggest reading Beats Guide to Network Programming. This book. This is just like 100 pages long, so that is pretty cool. We can just read it. Yeah. So this is better if you want to understand how these sockets work internally, like what is a socket and its structures, get added info, these functions. Yeah. If you want to get into what these things mean, then this is better. And yeah, so the theory part can be the whole project can be accompanied with this book. So I'm reading this off the stream, and yeah, so this is good for theory, and for the project building part, we will just stick to this thing. And today we are going to the next chapter, which is request response protocol. That is nice. Yo, hello, good morning. And I don't know what happened. I'm pupil again somehow. But shit, I'm not people anymore. Shit, what is happening? What is happening? Shit, what is happening? That is crazy. Shit, that is actually crazy. I supposedly became pupil in my second last contest, and then I gained 20 rating. But I remember in my last contest, I gained 21 rating. So this thing reduced. Uh, this thing was not this. It's- Yeah, things are happening. Random things are happening. Shit. Shit, I was looking at myself as a peasant, but no, I'm a specialist again, somehow. I guess this can be taken away very soon. Yeah, that is crazy. And this thing, request response cycle protocol, whatever. And this is cool. And okay, I will show you one more thing. When the guy comes up, his name is AY Eclipse. When he comes up, I will show you. He yesterday gave me a challenge, and I did complete the challenge. It was not easy, but it certainly didn't take 7 hours. So yeah, that was cool. Teamwork, skill server, attach, target is shit. I have changed. Yes, I have to change. N dot Emacs, Emacs sh. This is pretty easy to change. Substitute Redis with mist on the whole line. Emacs kills server. Emacs set. Emacs attached. Target is missed. Yep. Now we are in the project. So that is kind of nice. Something like that. This happened a month ago also, but it got corrected after some time. Corrected in the sense the ratings became as they were originally, or I yeah, that is actually crazy. So my peak was supposed to be 14, 17, but now it is higher, 14, 20. And shit, as much as I do not want the rating to judge, to be like to affect me, I am getting a bit happy. And I did became a bit sad when I became people again. But okay, this is cool. When I give my next contest, that would be cool. And now the server loop. Multiple requests in a single connection. Shit. Are we using mutex or something here? Accept. Okay, accept. Get a connection. If not, no connection, then continue. Wait, we are not handling this thing, right? Yeah. And then while true, one request, if one request is some function, okay. Error, if error, then break. Okay, inside while we have while, and then we close the connection, this thing. One request only serves one client connection at once. Okay, so this thing keeps running while while we have this connection thing, and if the connection breaks, then yeah, then we break and we close the connection and we take the next client. That makes sense. Okay, let's ignore concurrent connections for now. We will make the server process multiple requests in a single connection with a loop. Process multiple requests but not at the same time in a single loop, single connection with a loop. Multiple requests in a single connection with a loop. Okay, that means multiple requests with a single connection. Normally, I think what happens is we have a connection and like a client wants to send some request to the server. They make a connection with the server, make their request, server responds, and the connection is off. But here they are saying we are going to be like processing multiple requests with the same connection, with the same client. So, okay, so as long as client has something to send, the server will keep responding, and when the client disconnects from their side, the server will disconnect only then. Makes sense. The only serves one client connection at once, and through that connection, the server is processing multiple requests. Okay, cool, cool. We can do this. The one request function will read one request and write one response. The problem is, how does it know how many bytes to read? That makes sense. That makes sense. So we need a protocol, a simple binary protocol. We need a protocol for this. Yep. The problem is, how does it know how many bytes to read? So like, when should the, yeah, how many bytes it should read? That is a nice way to put it. Because how would the server know when the client message ended, right? Yep. This is the primary function of an application protocol. Usually, a protocol has two levels of structures. A high level structure to split the byte stream into messages. Second, the structure within a message, aka deserialization. Okay, two levels of a structure. A high level structure to split the byte stream into messages. To split the byte stream into messages. So, like dividing the whole request into a header and a body kind of thing. And then the structure within a message, aka deserialization. Okay, Okay, a simple binary protocol. We will do the first step is to we will do the first step is to we will do the first step is to split the byte stream into messages for now, but the request and response messages are just strings. 4b is like 4 bytes, one message, 4 bytes, message 2. How many messages are there? We don't know. We will do the first step, which is to split the byte stream into messages. Okay, we will split the byte stream, the thing that we want to send, into messages for now. Both the request and response message are just strings. Okay, each message consists of 4 byte little endian integer. Okay, we even have to specify the endianness. That is crazy. I guess that is required in this deserialization step. Each message consists of a 4 byte little endian integer indicating the length of the request. Makes sense. Each message consists of a 4 byte as in like 32 bits, little endian integer, where the least significant bit is the first thing that appears in the number at the first byte location, and the higher, more significant bits are to the right, like at a higher index, indicating the length of the request and the variable length payload. Payload, yes. This is not the real Redis protocol. We will discuss alternative protocols designed later. Okay. Now we have to parse the protocol, and they've just specified the protocol like this. That is crazy. Okay. So I don't get this protocol that they are using a simple binary protocol in which we have the length. Okay. First we have the length and then the message. And the length. Okay, shit. Okay. I guess this is the protocol. The protocol is like this. First we have the length, and after the length we have the message, and this length part and the message part are just like literally side by side, and this length part consists of 4 byte little endian number, little endian int. Yeah, that is the length part, and the message is just the like payload, which is, yeah, the message is what we want to send. And this is pretty cool. This is a pretty nice protocol. We can use this, right? Length, and what length is this? This is the length of the message that you are sending. We can implement this. We can literally implement this, and that is what. And this same protocol is used by both the sides. The server will use the same thing to send a response to the client, and the client will also use the same thing to talk back, to talk to the server. That makes sense. That makes sense. We can implement this server.cpp and shit. Okay, we would also need a parser which would parse this. Yes, literally, we do need the parser. That is what we mean by implementing this thing. So what would the parser do? The parser will take the first 4 bytes. Shit, this is crazy. This makes sense. This is little endian. That is the important part, because what will the server, the parser, see? The parser will see a long string. That is what the parser will see. And this string is made up of bytes. We have 1 byte here, 1 byte here, 1 byte here, 1 byte here. This whole thing is the length part, and then these bytes will continue. Let's make them red. 1 byte here, 1 byte here, 1 byte here, and 1 byte of data here. And this will like keep on going on. Okay, this is the length part of our protocol, and this is our payload. Okay, and these are 4 bytes, right? And we are saying this is in little endian representation, which means if we whatever the number is here, let's say this byte, since this is a single byte, one byte has 4 bits. One byte has 8 bits. So like 0, 0, 0, 0, 0, 0, 0, 1, 0, something like this. 8 bits. So each one of these represents 8 bits, and we can represent 8 bits using some hexadecimal number, where one hexadecimal character from 0 to F can be used to represent 4 of these 8 bytes, and therefore we can use 2 of these 0 to F hexadecimal characters to represent all of this whole byte, right? So let's say we can use anything like 8F1C, something like this. Let's say these are numbers, we can even have them 00, A, F, B, C, of course, and then 10, let's say. So we have, this is what our parser sees, and then these are different things. So this is what our parser sees, these different bytes. And how is our parser supposed to interpret this? This is supposed to be the length, and how is our parser going to know this length, what this thing represents? For this, we have to know what is little endian. This first thing in little endian representation, when you have a number, let's say your full number, which we are going to write in hexadecimal format, this thing goes to the rightmost 0, 0. This thing AF goes to the second last AF. This thing goes here B, C, and here we have 10. This is how this number is supposed to be interpreted. And this is called little endian because this least significant number comes in the front. So this number begins with the little end, little endian on the front side, and then we have, this is like at a higher place value, this number, then this number, and this number is to the right. Then we have the next number at the higher place value, which comes next, and then we have this number, which is the most significant number in this number, and it comes to the like rightmost place. So that is nice. Our parser can see the first number, add it. We can keep an answer or like length variable integer, which would initially be equal to 0, and we can literally like left shift our number by 8 bytes, so that no, 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 this is what we want. So we can start reading from this side. We can take this and our number would become equal to this thing. Then we can left shift our number by 8 bytes, and therefore we will get 10 and 00, and we will add the next byte, which is BC plus BC, and we would get 10 BC. Then we will left shift this by 8 bytes again, and we will get BC 10 BC, and add the next byte, which is AF, and we will get 10 BC 0 plus AF, and we will left shift this again, 2 more zeros, and plus the last least significant bytes, which are 0, so 0, and we will have our full number BC AF 0, 0. This is going to be our length, and we can run our loop, which is going to read this whole thing till our length becomes equal to 0. So that is nice. That makes sense, right? Are you revising it? Can we simply swap? I mean, this is the way that we are going to use to swap this, right? Mm, because you have this in a string format, like a array of characters. So yeah, you have this in the form of array of characters, So how are you going to read it? Right? You have to systematically place things where they are supposed to be. And this is how you do it. Like this is one way. I guess there must also be some other ways where yes, you can begin reading from the start, read this, add this to your answer, and when you get the next number, you can left shift this next number by 8 or whatever the current offset is. So what you will be doing is you will have answer initially equal to 0. Let's say you read the first bytes, which are 00. You have 00 A F B C 10. You read these two bytes. Now you are reading these two bytes AF, and what you will do is answer equals the original value answer plus AF left shifted by 8 times. So AF 00, add these two and you get AF 00. Now this thing, read this and do AF00 and left shift this thing by 16 bytes so that you get two zeros, and these zeros are hexadecimal zeros. Therefore, when when you are representing a number in hexadecimal format, this 10 represents 4 bits, and so when you left shift this number by 16 bits, you can represent those empty 16 bits with 4 zeros, which would mean BC 00 00, and you add these two, you get BC AF 00, and you do this once more with this, shifting this number by 36 times. 36. That is too much. 16, 24, 24, not 36, yes, 24 times. We have to left shift this number by 24 times and add this to this number, and we will have our whole number. So yeah, those are the two ways we can use. We can parse this. Let's now write the parser, but also this is very subtle because let me actually show you. So here we have handle client, and let's write this whole thing again from scratch, right? Yeah, let's write server um request dot cpp, right? And in the main, and we will have a file descriptor include sys slash socket.h socket. We want this socket to use IPv4, which is represented by AF inet, and we want to use TCP connection over this socket. So socket stream, and we want to use IP, so and which is represented by 0. That is just the convention. And now on the server side, we want to set some options. We can say static int on equals 1 and off equals 0. We are just going to use these two integers whenever we want to say on or off for setting some options. So that we don't have to create new variables randomly. We can just use these two. Set option, set socket option, my bad. Set socket option. First argument is going to be which socket to set the option to, and now what layer in the whole OSI model protocol, OSI model, which layer we want to set this option to. SOL socket. This option will be set on the socket layer. And now what is the option that we want to set? The option is SO reuse adder, which means that whatever address we are going to use in this listening socket can be reused again and again by our server to listen. Yeah. And now we have specified which socket to set the option to, which layer to set the option to, which option we are setting, and now what is the value of the option. The value of the option is on, and we also have to give in the size of on. Now, the option is set. Now, what do we want? We want to set an address to the socket to listen to. And for this, we need a struct. Uh, struct adder in. And we will call this adder, which is initially empty. Now we want to add detail to this adder, and we want to add three things. First, the port on which our server will be listening, the IP address on which our server will be listening, and yeah, the version, also the version of this thing, which is IPv4. So we do addr dot syn family is the same thing we gave above, IPVnet, AFnet, which means just uh, IPv4 version, which is specifying the version. And now the port is H host to network small, HTOS, and the port. So what does this function do? This function is simply a macro, or macro is simple static function, which takes in a number, and this number could be represented in any way in our computer. Our computer could be using, there are like literally two things for representing number, two ways, little endian, like this thing, little endian, or big endian. There are two ways, and the internet uses big endian, but our computer might be using little endian, so we have to do some conversions, and this function just makes sure that whatever our host is using, this number is represented in the big endian format which the network is using. And this S means small, that is, this number uses 16 bits. Yeah, 16 bits. I think we can see. Yes, unsigned 16 bits. And now sn address dot saddr h host to network long, and like, uh, this thing just means localhost. This is the address, so IP address and the port. And now we want to bind our socket to this port. And then it was bind the socket FT given. Now we have to give in the address of this adder and size of adder, but just giving the address does not work. We have to transform this pointer to a const struct adder sock adder pointer. Now it works. And these like subtleties, the fact that why do we have this key which only has this one value, like this is redundant, this is just bad design, purely bad design. And why do we have to convert this pointer into this type const struct sock adder? That is just bad design. And this function bind returns 0 if there is no error, and -1 if there is an error. So what we will do is we will say p error, print error if n exists, and if n is -1, we would go into this situation and we would say couldn't bind the socket. Nice. Now we have bound the socket. What do we do next? Okay, they are stored in strings, and I have something for you. If you would like, github.com nvim rc, I would like you to check out something. After I do write this whole thing, I will show you manually, but before that I would like you to check out something I wrote. If you go to my remaps folder, there is a little new remap here to run the current CP file in a temporary buffer. I would like you to read this, and I don't mean like everyone, but specifically this guy right here. Check this out. And after I do write this thing, I will get back to you. This is amazing. This was not trivial, I would say. This was not trivial. This was a bit, yeah, challenging. Now, our socket is binded to the address. Now we want to start listening to our socket. Listen on this socket, and we have to see how many clients can the operating system add to the queue of pending clients, how big the client queue can be. Let's say 10. Yep, now we are listening. And if n, so this listen function also returns either -1 or 0. If 0, that means success. If -1, that means error. If error, we will just output error. Couldn't listen on the server, on the like socket. Okay, now we are listening on the socket. What do we do next? We just run a while loop. Yes, while true, keep running this loop. And what we do here is, so what does this listen function actually does? This listen function tells the operating system that in this socket, whatever the address is attached to this socket, which we binded here in this step, if there is some incoming request on this socket, on the specified IP address and port, if there is some incoming request, then accept the request, make a TCP connection with that client, and put that connection onto a queue. And that queue cannot be greater than 10. That is what we are just specifying right now. And now we have to accept, like, if there are some clients onto our queue, we want to take those clients off the queue and process the client however we want to. For that, we first of all need a same thing, this thing, address thing for the client, so that we can get details about the client, from where the client is coming and stuff like that. So we do struct sock adder in C adder client address, initially empty. And the way that we pass in this thing is kind of crazy. I don't know why it is this way, but this is how it is. So now we have to say saw length type. Let's say length is equal to size of C adder. We have the data structure in which the we have the data structure in which the client's address will be stored, and we have the size of this data structure. Now we want a new socket through which the server can communicate with the client. For this, we will say CFD, like client file descriptor, with, and we get something using the accept function called accept the thing, like get us the top client connection from the queue of all the client connections from this FD file descriptor, and store struct sock adder pointer address of C adder. Give the client address, convert it, typecast it into struct sock address pointer, and here instead of passing in the length, we have to pass in the address of the length, which is which like does not make sense. Yeah, we have to pass in the address of the length. That is how things are. Yeah, that is how things are. Now we have to check for error. If CFD is smaller than 0, that would mean some error happened, and we would say P error, print error, couldn't connect to the client, and continue. So that we can start looking for the new client. And when we do have a connection with the client, yeah, we just process the file descriptor, and we will process it the same way that is written in this thing. when we get a file descriptor for the client by accepting something, then here we check for the error, and then we run a while loop, which is requesting requests till the connection is valid, and then we close it and we process the next client. Wait, stream freezed? It is working. Seems cool. Run your code once. Okay, let me run. And also, did you enjoy learning? Yes, yes, it was amazing. It was amazing. It was amazing. Yesterday, learning all that thing. Here, let me show you. N circle. Let's say I start something, and I want to test this thing. Compile. Hmm. It took 1.9 seconds to compile, and the degree of precision, you asked me for 5. We have 10 here, 10 degrees of precision. And we have one test case, 5 numbers, 1, 2, 1, 2, 3. Answer should be 3. Answer is 3. So code is working. This thing is working. That is cool. And also the fact that, yeah, I have some comments here. We must use terminal. Shit, this was quite a bit lot. Yeah, figuring this out was very fun. This was very, very fun because I was thinking maybe we can use Lua for calculating time, but no, Lua is calling an API and Lua does not know how much long the API runs, so we cannot use Lua. We must use the bash version, which comes up when we do terminal bash. So this bash version is the only place where you can run, but this is a minimal version of the bash, not the full bash version. So we don't have the epoch clock command, which we normally have, which is this echo epoch real time. This is the time since the conception of the universe, since 1971. That is when the universe started, 1st January 1971. This is very high precision clock, but this does not work because the image of batch we are using is very minimal. What does work is the date command, and we can get precision in date plus s com dot n. Now we have precision, but we cannot use these commands, these percent things in Vim, because they mean something in Vim. So we have to escape these things like this using backslash, and this was very fun. This was very fun. And shit, since here we just cannot do end time minus a start time because bash does not do floating point arithmetic. So we have to take this thing, and this thing is going to be interpreted as a string. So we will literally get one number, a hyphen, and the second number, and we are passing that thing into this BC function, which is used for arithmetic things, and we are putting this new integer which we get into this variable in the bash, and then we echo time to compile, duration, and then run the file. We start, then we compile, then we take the end time, and then we set up the duration and we print the duration. That is crazy. That is crazy. That is crazy. Actually, it was like pretty fun, very fun. It was only good for writing Vim options. Lua doesn't know how much time it takes for the external API to run. Yes, exactly. Along, it was me and my friend both were doing it, and we were also waiting for Team Impala to drop his album. So about 3 to 4 hours. Yeah, 3 to 4 hours. Certainly, yeah. Uh, Certainly, it didn't take 7 hours. It was kind of tough. We cannot use Lua since we are here using Vim API, and after calling it, Lua goes on its merry way. So we cannot use Lua. And Bash doesn't have floating point subtraction, so we use BC command. And we have to use Vim to compile since we need the name of the file. Yes, we have to use Vim to compile because otherwise, how do we know the name of the file? So we must use Vim, and time management system must be in this Bash because we want to present the thing on the bash, and the compilation is also happening on that internal Vim bash terminal bash window terminal window of Vim. This was good. This was good. If we use terminal, we get minimal bash ISO, and we must use terminal. Yeah, these were the like learning lessons we took from this. So this was pretty cool. This was pretty cool. I took 7 hours alone and failed miserably. Anyways, the bind is now goated. Yes, the bind is now goated. Did you do it? Like, did you get the whole thing? And I also like this fact. I think the most genius part, my most genius contribution in this is this, that I split the command into multiple readable chunks and then calling it using concatenation, string concatenation. So this was cool. This was cool. This was cool. This was cool. This was very instructive. Yeah, this is now good. BC is pretty interesting. It has its own kind of programming language, even the Linux. Okay, I didn't know splitting is yeah, that was good. That was I actually believe it was pretty cool to split, but now it seems very obvious that we should split. Yes, that was cool. Okay, I just used BC to do the arithmetic. I'll come with another challenge someday. Okay, find a more difficult one, I would say. BC is pretty interesting. It has its own programming language. Even the Linux kernel uses BC to calculate compile time constants. Huh. I didn't know BC was a like whole thing on its own. Arbitrary precision decimal arithmetic language. That is the full form for BC. And they only have C. They none of the word has the letter B. Somehow it is called BC. Yeah, has its own little thing. And now to socket programming. We have our socket and we will run a while loop and we will do int air equals process one request. We will write a function which returns an integer one request and it takes in a file descriptor for the client. We'll name it client file descriptor and return 0. And this function one request will be called here on the client file descriptor, and if air, we will break this while loop. And I don't know, why do we have to close on our own side? Okay, we can close on our own on the server side also. And what was the error? We were not including something, I guess. We were not including this thing. Yep, this is it for the server side, but we now have to make our own parser, which parses the protocol. Yes. Okay, I think now I should open the Bible for you. You want something tough, right? Uh-huh. Yes. There is a DC2. BC and DC. Don't know much about DC though, but BC is pretty good. Try learning the BC programming language. BC is a programming language. I thought B is a programming language. So BC is a programming language, a whole programming language. Chicken is a programming language. Citron is a car company, but it is also a programming language. BC is a programming language. Shit, that is crazy. That is crazy. And right, going back to writing our own parser. Not exactly a programming language, kind of like shell, I guess. Yes, that was clear, but for the audience, so that we don't know, we are not getting into some cultish thing. It's more like scripting for BC, like Tmux scripting, something like that. Okay, now writing on our own parser. What will the parser do? I guess parser should just return the length. Yeah, parse. Let's write the length reading part and parse length. This will take in, shit, what will this take in? This will take in the file descriptor and Wait, but what if this thing reads more than the thing? No, I can just say I want to read just 4 bytes. Keep everything to yourself. I just need 4 bytes. Int len equals 0. This thing is an integer. And yep, let's character len length buffer, and the size is going to be 4. And initially everything is empty. And then we say int n, let's say read from CFG, this file descriptor, read into length buff and size of length buff. Uh-huh. And let's see what are the errors which are given by this. Return values. This thing, if success, returns the number of bytes which were read, and if error, then returns -1. Okay, and also n bytes. What is size t? What is size n bytes? Number of bytes. N bytes. Okay. This attempts to read n bytes from the data. So, okay, we will be attempting to read 4 bytes from the data. Cool. If n smaller than 0, that is, we were unable to read data from client. Okay. If this error does not happen, let's say we also exit with error code 1. Wait, we don't have exit. Exit with error code 1. Okay, if this does not happen, that means we were able to read. Now we have to actually parse this length into length. Okay, so for int I equals 0, I less than 4, I plus plus. Let's have a const in length size equals 4, because this could change in the future depending on our protocol. Length size. And okay, so now what do? We read the ith byte from the data. Yeah. Answer or length plus equals char. Okay, we have to first read int, let's say it's c equals length buffer, the ith thing from the length buffer. And so this is an integer length buffer. We have to left shift this I into left shift this thing I into 8 times. Yeah, should see. Yep, we will left shift the second number twice, like 8. Yeah, this is okay. This is okay. And then at the end, return length. This is working. We can actually test in length equals parse length from this file descriptor. So we get the length of the message, how much we have to read. That is the length, how much we have to read. Okay. Scripting. Bro said multiplexer. Huh? Shouldn't you write parser in its own file so that it can be extended and refactored easily later? Okay, we are not going production level right now. All right, time for me to sleep. When you sleep 22 hours, were you listening to Team Impala? Take care. Take care. Be healthy. Okay, we have our own parser Yeah, we can extend it later. Right now, we are just testing. We are just reading a simple length. Yeah, shit. Uh, yeah, making this parser into its own file would be good so that the client and the server both can use the same parser. Dry code. Okay, now we have to read, and we have to read string, string, let's say message, MSG. Yeah, message. Message initially is empty, nothing. And we will keep reading while length. While length. We want to read length amount of message. Okay. Okay, let's read this in chunks of, let's say, size length. No, shit. What we can actually do, since we already know the length of the message that we want to read, we can just say how much and what. We can say size of this string is going to be length plus one, because at the end we might want to add some new space, and everything is zero. Okay, this is the other way around, I guess. Length plus one. Shit, we have to change these brackets. Length plus one, comma, zero. And I have to put my laptop on charge. Okay, it is charging now. Cool. I was switching distros. Yes, you did say I wrote and wait. Yeah, you did say you were switching distros, I guess. Yeah. Moving to something else. I wrote an entire shell script to automate installation of required files and it crashed, but it crashed. So I had to reinstall the distro first, then redo everything manually. Okay, you are working way too hard, I guess. 22 hours. Yes, that is too much work for a single human being. We need to add stuff to this thing. Offset initially 0. Makes sense. And shit, we don't even need the normal string. We can use char pointer here. Empty. And what is variable size object may not be makes sense. It, if not, okay, this thing is working here because lens size is constant. If this was not constant, then we get error here. Okay, so this is variable length, and we cannot have something variable length on the stack, so we need to use malloc. I do not want to use malloc, so let's use a simple string. If we are going to use a simple string, then how do we get the underlying string pointer or thing? What we can do is we can use a string std called message, and we can keep appending the answer to this thing, and we can keep reading in chunks. Yeah, we can keep reading in chunks. Chunk length, let's say length of one chunk is 128 128 bits. 128 bits is not a lot. 128 divided by 8 would be 15 characters at a time. 15 characters at a time is not a lot of memory. Let's say this, let's use this as the number of bytes. Let's say we are going to read 128 bytes. That would be 128 characters in one time. So that is faster. So what we have to do is, yeah, we have to now initialize char array uh, read read buffer, we will call it, and size is chunk length, and initially everything is empty. And now int size, or like how much we read function on this CFD client file descriptor, address of our read buffer, and size of our read buffer. Okay, now we have to check for errors if size is smaller than 0, or not. Just this is fine, this is fine, this is minimum of. Okay, we have to see that we either return the size of the read buffer or size of int size of char multiplied by length, because the length of the remaining message could be, wait, min is not defined, because the size of the remaining message that you want to read could be smaller than 128 bytes. In that case we would just say read 128 bytes and read the remaining characters from our message. Okay, now sz is smaller, which means we got some error, right? sz minus 1 means error. So the error couldn't read data from the client. Okay, after this, we do know that we have read some data from the client. What we have to do is append that data onto a message right here. So how do we extend a string? We, yeah, how do we extend a string? Shit, shit. I messed up a little bit. Close. I messed up a little bit. I have to go here and open Ghosty. And the amazing thing about Tmux is we can just start from where we left, right here. That is cool. Now is how to append uh, char array to string C++. Append, literally the thing append. My string, which is a string, dot append this thing. And what if I want to just say I want to add a subsequence? Okay, we could even use the plus thing. Okay, we could use append new string, which has char array, and then we can append the temporary string onto our main string. That is also one thing. Okay, no, we don't want that. We do not want to add the whole thing. We want to add a part of this whole 128-bit thing. How to append a sub string of char array onto a string C++. That would be a little bit more complicated than this. Okay, yeah, okay, that is cool. That is cool. Starting from here till this. Okay, this is the size, and this is the starting index. That's cool. We could have seen it like right here if we did msg dot append. There are 10 overloads on this thing. Okay, append what we want to append. We want to append our read buffer, and how much is it? That is how much we read from this thing. Wait, if we were unable to read, or if this thing returned, yes, shit, we will not exit. We will say here return -1 when we are asking for length. And here we will see if length smaller than 0, if -1, that would mean error, in which case, which means you were unable to read. So that would be interpreted as there are no more requests. So we can return -1. -1 means error. Okay. And yes, here p error when we were unable to read, then we can return -1. After this, we append this much there. Cool. Cool. Yeah. Our string is ready. What do we do? We can, after reading the whole data, we can printf the thing and say client says a string which is MSG. Wait, shit. Error? Yes, error. Error. Yes, error. We will have to say msg.cstr. C style string. And if this, then return 0. We were happily able to do something with the client. So we can even write this into our parser. This should also be written to our parser. So our parser would directly return the length, not the length, the message. So the parser is supposed to return this, but we cannot return an integer and also a string. So what do? We can create a structure which would help us. This was nothing. It took 5 hours max, but I realized I forgot pushing my i3 window manager's configuration and rewriting a window manager config is easy, but time taking, like manual labor. Return runtime. Do you prefer vectors or normal tables? What are normal tables? I prefer vectors. Like that is what Jan Strausstrup suggests in his book. I'm sorry, but for me, I don't understand why you need so much code unrelated to making the requests. But okay, explain if you can, I guess. Okay, wait, this is not so much code. I don't think I've written anything that is unnecessary because we this part is reading a chunk or like how much it can read, and then after reading it is appending whatever it has read onto a final string on which we are adding our whole input. And shit, we don't have to read this offset. And shit, I also messed up at one place. We have to do length minus size because we just read size. Yeah, I don't think there is anything unnecessary in this. All of this is necessary. We need length, we need to read the buffer, like the size, and we are always checking for errors, like good human beings we are. So that is nice. And then a string to read the thing. And now we want to return the length, but we do not want to just return the length. Yep, we do not want to just return the length. We want to return the string, but sometimes we could see an error, in which case we do not want to return a string. We want to return that there is an error we were unable to read. So I guess we can make a struct for this, which might be over engineering, but okay. Because how else would we do this? We cannot say that the return type is string or a reference. How do we specify that our parser got an error? So we should use a struct here and call it parse return type. And yes, I guess we should ship this whole part into its own file parser file, parse return. This would have a standard string, let's say MSG message, and a length path. Wait, a standard length is like nothing, doesn't make sense. Length. Okay, and this thing, our parser returns uh, parse return. And here, what we return is an like, empty string. But yeah, this is our value -1. We can declare this thing at the top, and here say MSG message, and print and print shit vim 3 copy 10 here also print. Okay, and here instead of returning the length, we can return structure where the length is msg dot length. Size int. Okay, cool. It is working. And here we are taking auto parse length. We'll change the name of the function and pass in cfd file description. Auto parsed equals this, and we are saying auto msg reference auto reference msg comma len equals parse, which we can do in the same step. Here msg message and the len. Uh-huh. Parse return cannot bind to a temporary type of return parse return. Okay, that is some error. Okay, we cannot use that. Okay, msg and we also have to check for errors. Hello, with C++ version and compiler are you using? For compiler, we are using GCC, G++, right? And the C++ version, I guess, the C++ version. I have read C++ 11 from Mr. Björn Straustrop's book. So I don't know features in the newer versions. Like, this is pretty old, but this is my old reference. So I'm still learning the newer features. Like there is the range function, I suppose, and newer things. And yes, there is the fact that we can, in newer versions, unbind a tuple, which is pretty nice. We don't have to use get function to get something from a tuple. We can just unbind a tuple using brackets, using parentheses. That is nice. So mostly C++ 11, but I am learning newer features and newer versions. That is nice. For length as it is unsigned integer. You can use string size type for length as it is. That makes Will that actually make sense? We don't have to specifically use integer there. Size t, that would also make sense. But then now we have to typecast these things. Hmm. Yeah, we have to now typecast. And shit, we have to use integer because we want to here represent negative numbers. So you must use integers. Size t cannot have negative values. Or maybe we can express an error zero, with zero length. And if we are expressing error with zero, then how do we differentiate between a message where the client literally didn't send any message, just a empty string, and an error? Yeah, so I guess we would have to use -1 for error, and if there is a empty string which the client sent, for that the length would be zero. So I think we should use integer here. Yep. Yeah, these things are pretty cool. Negative. Yep. And here now, if len is less than 0, then we got some error. Return -1. And before returning, do you want to print error? Yeah, maybe not specifically error, maybe the client ended the connection. Okay, cool, cool. This is server-side thing, and we can copy this whole thing into its own file. Okay, missed. Shit, shit. Okay, shit, I have to update my dot that's RC. Uh, should be called missed and missed. That is the name of the project. Source.exe is our RC missed. Okay, we are here and let's write parser.cpp and chunk size, length size. These are parser related things. We can copy this whole thing. Yeah, this whole thing is the parser. Paste. Include string and what else? Shit. The keybinds, shit. I'm confusing myself between the Vim keybinds and the Tmux keybinds for switching windows. Shit, okay, cool, cool. This is something that we need. Okay, and are there any more errors? Nope, nope. And here we can include it. We can literally say, wait, how do we include files which are literally right here? I guess we use this. Or shit, we haven't saved the thing. Ah, how to include file in the same directory cpp my.h. Wait, header file. We have to define a header file, but we can maybe just include the whole thing, the whole file, .cpp file, or do I have to write a header file and then add this cpp file at the linking phase? That would be too much work, maybe. Shit, if that is what we are going to do, then it would be better to use a make file so that we are not manually adding every cpp file in a project. Shit, this is getting out of hand. And yeah, we are like way off from the project. This thing just said This is the protocol, and I haven't read how they are implementing the protocol. I just went off implementing my own thing. Okay, so parser, we have to add parser. Maybe the LSP doesn't know that the parser is there, or like the new file is there, the header file, and yeah, with quotes, double quotes, parser.cpp. Redefinition. Okay, yes, it is working. It is working. It is working. Cool. 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 It is working. It is working. Cool. We have our parser.cpp. We are including the whole file. That is nice. Okay, this is working here, and we can do the same thing on the client side. Let's write the client side code. Client. Okay, what do we have? We have server request. Let's write and client request.cpp, and here include this slash socket.h, and whatever we need we can include later. And file descriptor for the socket, we are going to use IPv4, and we are going to use socket stream, which means TCP, and 0 just means the IP protocol. And after this, what do we do next? We have to make a we have to make a address structure which tells this thing, this socket, the address of the server to which we want to connect, and then call the connect function to connect to this socket to the server. Structure adder sock adder in which exists in some file. We have this thing. Yeah, cool. What? I guess this is the file. Inet include net inet dot in dot slash n dot h. This should be the file, and here we will define the address, which is initially empty, and now we have to add the port, the IP address, and also the family dot sn family, which is AF inet, which we used above to specify IPv4, and add send port. Port is going to be host to network. Small port is 154. The same thing we used here, this thing, instance, yeah. And then the family, the address, adder send adder dot x addr. This is just inconvenient. We have a structure which has this key which points to another structure which which is redundant, like we don't need it. And this thing is going to be a host to network long, and this is so reuse. No, should I forgot what this is supposed to be. This is supposed to be the IP and the localhost equivalent in sockets, and client CPP. What is the thing? Yep, in address loop back. So address of the same machine, because server is also going to run on the same machine. So yeah, in addr loop back. Cool. We have our structure now. Just we have to connect in n equals connect file descriptor. This one, this socket, connect this socket, and we have to give in type, given the address of this adder, the server address, and size of adder, but we have to also type convert this address into a constant pointer of this not the same time, not this structure, but a constant pointer to another structure, which is like crazy and inconvenient, very inconvenient, but this is how things have been. So add pointer. Yep. Now we check for error. If n smaller than 0, or if n equals 0 means the connection was successful, and n equals -1 means the connection failed. Some error occurred. Connect to the server. Cool. And if this p error, okay, we don't have the file include std io not studio. Okay, and after this, we do have a reliable connection. Shit, we also need a not a parser, but a reverse parser to which we can give the length and get the literal bit string that we are going to send. So that would be nice. Bro, have you considered using Zig? It will be great for such a project. Bro, I'm learning Rust right now, and yes, I'm learning quite a bit new things. This whole thing itself is pretty new. So yeah, I'm learning this thing, and learning this in a language that I do not understand would be a bit too much, but I do want to learn Zig. Do you know the Zig motto? I think it is. No, it is not Zig motto. It is Haskell's motto. Haskell Foundation motto. Look at this. Their motto is avoid success at all costs. That is their motto. Mm, Like that is their literal motto. Avoid success at all costs. Haskell's motto, which is crazy. Yeah, Zig, not right now, but yeah, in due time, I will learn Zig. Zig is a pretty cool language. We can, if I learn Zig, I would be able to contribute to Ghosty, which is nice. And yep, we need a kind of reverse parser to which we can give the message, the payload which you want to send, and that parser or reverse parser or formatter, I think would be a better word. Formatter would format that message, that payload into the way that the protocol is defined. Okay, and this is the protocol. Length and then message. Length, message. Length is in 4 bytes. Then message, whatever the length was, that is the length of the message. So write. Let's change the name of this parser thing to format.cpp. That is a better name, I guess. We are not seeing any error here. Format.cpp. Okay. And yeah, let's include format.cpp. Uh-huh. And okay, now we here have to write a entire parser, I guess, and that thing will take in a string. And what is it going to return? It is going to return a string. It can return a string. That would be nice. But yeah, it can return a string. Shit. We have here taken care of the fact that in one read operation, we might not be able to read the whole message which you want to read. So that is why, while the length of the remaining message which we have to read, while that thing is not 0, keeps reading and appending to the message. I think we have to do something similar when we are doing the write operation, because maybe in one operation we won't be able to write. Shit. We won't be able to write in one operation. So we have to do a loop till we have written everything that we want to write onto the socket. We will keep writing. Okay, before making any progress, let's get back to the article and read it. What are you writing? C and Zig is a future of C. You are doing good too. Yep, thank you. Yeah, I mean, this is for toy, like toy project for learning. And also I haven't made any projects in C++, so that is also helpful. Yeah, but this is more C than C++. Like this, nothing is object oriented. And should we use something object oriented? Object oriented would kind of make sense. We could just say socket dot read and give it our own parser of how it is supposed to read the um, payload. That would make sense, but I do not want to use object oriented because there was one man, Casey Muratori. He said, big oops, anatomy of 35-year-old mistake. He said, object-oriented programming is bad. Do not do this. So yeah, I don't have my own opinions. He is guiding my opinions, and I'm going behind what he says. So yeah, no object-oriented programming. Yeah, I don't think we need it right now. I don't know. Okay, let's see how they are writing the parser. Check the return value of the read write. Uh-huh. Read write returns the number of bytes read or written. The written value is -1 on error. Read also returns 0 after end of file. That makes sense when it end of file or end of connection. But our connection will keep persisting till we end the connection, because on a single connection we are handling multiple requests. So yeah, the client might, after sending one request, the client might send another request, in which case we just want to read the first request and parse only that much. Okay, see, these are the function prototypes, the things, okay, function definitions. To read a message, first read the 4-byte integers, then read the payload. You may imagine the read side like this. Max payload, okay, read this thing onto this, and shit, this is bad because of the endianness. This is bad because of the endianness, and I guess this should ooh, this should not work. I mean, we are just making one read call, and we might not read the whole thing in just one call, and that is one bad example. And imagine the right side like this. Write the length, and then write the protocol. And if the length of the thing that we have written, RV, is not equal to the length that we wanted to write, error. Shit. Both are wrong because both are wrong ways to handle a TCP socket, because read write can return less than the requested number of bytes. Yes, under normal conditions, no error, no EFI. Why do they behave this way? Explained later. Yes, the deep theoretical knowledge, no, that is not the right word. Uh, we can use this thing to refer back to this thing. This is an amazing book, but I guess reading this on stream would not be a good idea, because that would just be pure theory. Yeah, PDF in black and white, that is amazing. Yeah, theory, just reading theory would be very boring for the people watching, I suppose. I also recommended watching Data-Oriented Programming by Andrew Kelly. The main reason of using structs is performance, because they can be cached easily. Yeah, because you know the size of the struct beforehand. Shit, Andrew Kelly, I guess Andrew Kelly was also on that same conference in which Casey Muratori gave that talk of his. Andrew Kelly. Okay, this might be it. Andrew Kelly. I have not seen him before. And Zig creator Andrew Kelly. Should that is crazy. Okay, he created Zig. Uh, and GitHub Zig Moto, Zig language. Yo, we have him. That is the guy. And I also like one thing about this, about Zig, that the whole documentation, I guess, is in a single page. Guide, Zig build system in-depth overview. Yeah, this thing is one page. In a single page, you just go through this and get the basics. That is nice. Learn news, download, dev, join a community, Zig Software Foundation, and just get started. Yeah, Zig is cool. Zig is cool. Zig is cool. Compile time faster, and I guess toolchain for maintaining robust, optimal, reusable software. I guess their main motto was to be better than C, better version of C. The first video was the okay. I'll watch it. I'll watch it. Their main motto is, I guess, Andrew Kelly. Yo, let's go. Zig is faster to learn, offers more flexibility and is ideal for developers who prefer C-like approach without all the Rust specific rules. Rust is like too specific, be this narrow way, but Rust is pretty cool. Rust is also pretty cool. It has pretty nice ideas. No, you cannot. Can Zig replace C++? No, you cannot. Write Zig code instead of C or C++ code. Okay, whatever the lore is, this one is the talk. Yeah, this thing. And yep, right here. Both are wrong ways because we do not always read how much there is to read and do not always write how much there is to write. And why do we get this behavior? A common mistake is to assume that a read somehow corresponds to a write from the peer. No, I guess there is a internal buffer maintained by the operating system. This is not possible because a byte stream does not preserve preserve any boundaries. Okay, is that like the whole definition? A common mistake is to assume that a read somehow corresponds to a write from the peer. Wait, why is that a bad misconception? This is not possible because a byte stream does not preserve any boundaries. The video is not related to it, but it is pretty good. Yeah, you can watch it. Object oriented. Let's go and read full, write all. Fit there are we can write our own versions. Okay, to actually read n bytes from to read write from to a TCP connection, you must do it in a loop. Okay, so our solution was not trivial. It made sense, I guess. It made sense to use a while loop there. Static, okay, on the stack, not on the stack, on the static section of the memory. This will return an integer, read full file descriptor onto this thing. The size of this thing is this thing. Okay, while n is greater than this, read size type, okay, if this thing is less than equal to 0. Okay, this is something that we can make equal to less than 0, make less than 0. Okay, so I guess this is a type which we can actually use there. Size, uh, S size t. Yep, and we are not getting any errors even here. Okay, we are getting some error. Shit. Static cast this thing into this thing. That is crazy. Okay, yeah, I guess integer was fine. Integer was okay. No, integer is not very professional. S is size and we are casting it into integer, which is automatically getting casted into another thing. Static cast is not good. Static cast is like reinterpret the bytes which are representing this number into this type, which is not really good. This is fine. And okay, so while there is something to read RV amount of size, and if this is less than 0 or something, and okay, then return -1. And yes, we got 0 size even when we wanted to read something. So that is also an error. And then assert that RV is always smaller than equal to n. That is true. That is true. That is true. That is true. Then remove this much from size and buffer plus equals RV, which increases the pointer of the current buffer, which we are going to pass in next. Okay, that is crazy. That is okay. That makes sense. That makes sense. We can do that. And this assert. Okay, let me add assert. Okay, we do assert. Assert that size is less than equal to length. Okay, how do we use assert? Assert and then assert is supposed to be included. Assert. See assert. Okay. And then this thing is for write the whole thing, whatever we have. Okay. While there is something remaining that we want to write that thing into this buffer. I think this is better than what we are doing. Yeah, this is better than what we are doing. Parse the request and produce the message. So first get the length of the whole thing and then read full and then get length of what we want to write, request body, do something we write and we do write all. Okay, that is nice. That is nice. We will use this implementation. That looks nice. And we have whatever a read returns is accumulated in a buffer. It is how much data you have that matters. How much a single read returns not. Yes, how much a single read returns does not matter. What matters is what is like the whole of what we have read. That is the thing which matters, which makes sense, which makes sense. Okay. Now the parse the request and produce the message. Okay, so first before parsing, we will, I guess we can rewrite our own parse function into this form to adhere to this thing because we are using this as a guide now. Yeah, I guess we were doing more than what was needed. You were saying the same thing. Yeah, shit. And okay, so how is the function going to look like? This is going to look like it will be returning an integer and read all. It will take in an int file descriptor and a char pointer, uh, buffer to the buffer and int n, how much we are supposed to read. And now what? Now we can just start a loop while the things that we have to read is greater than n is greater than 0, while n greater than 0, n cannot be negative. Then we will do a read call. RV makes sense. RV stands for receive, I suppose. Read onto this descriptor, pass in buffer pointer, and how much we want to read. The size of this buffer is n. Yeah. Now, if RV smaller than or equal to 0, then return -1, error. -1 is error. Okay, after we have read this, assert, what is the expression? RV has to be smaller than equal to n. And after this assert, yeah, we increase buff plus equals RV. That is how much we have read. If we read, let's say just 1 byte, then we increase our pointer to the right once. Makes sense. And then subtract from n RV. This is how much we have read. And yeah, at the end, return 0. 0 means success. Okay. And now write all takes in a file descriptor and star pointer to what we have to write and how much we have to write. While n greater than 0, while there is something remaining that we wanted to write, receive a request. Okay, they were using RV. I guess RV does not stand for receive because they are using RV for both write and read. That is just some nuances for naming things. Write buff or on this file descriptor from this buffer n bytes, and if RV smaller than equal to 0, that is we were unable to write anything or we got an error. And when RV equals to 0, that is also an error because here n is greater than 0. That means there was something we wanted to write and we were unable to write anything. That is error. Now after this, assert that the things that we have written is smaller than what we had the capacity to write. After this, we can increase our buff pointer by this much amount and n minus equals rb. This is smaller than what they have written. No, this is exactly the same that they have written. Shit, this just seems, I don't know why this seems more complicated than the one that I have written. I guess because they are using size t here and I'm using integer, which is making things easier, I suppose. That is nice. That is nice. Let's use int 32t. That is just same as an integer, so we don't have to do anything with that. Size t. Let's use size t to be more professional. With no error, I suppose. And we can also make these functions static so that there is just one instance of them, which is on the stack part of the memory. And we can remove everything else. We can remove everything else. Our amazing parts function is gone. Alas. Yep. Alas, as in ALAS. Chunk size, we don't even need chunk size. We don't need length size. Read and write all. These are the functions. Okay. Let's also write a little function for parsing the length. Not write all. Uh, parse length takes in a file descriptor and just that. This will return an integer. Let's say char len buff size 4 equals initially empty. And no, end rem equals 4. 4. Great. Okay. What we can do is call our newly written read function. Int n equals read all from this file descriptor len buff. I guess we have to give in the address of len buff and then size 4. I don't like using 4. Wait, what was the problem? Okay, okay. I don't like using 4 here. Let's say we have a constant number at the top. Uh, Len size is 4. If it's an integer. Substitute substitute 4 with len size. Okay. Now if n smaller than 0, that is an error. Return minus. Otherwise, if we did got something, then we have to write a loop to get the answer. Or what we can do right here is this and return answer and -1 here. Yeah, -1 here. And after this, we have to interpret these 4 characters from little endian to our own big endian interpretation. Yeah, you can also do standard, expected, optional. Wait, I don't know about these two functions. Where do we use these? And expected is a function in Rust. And optional, I don't know. I don't know these two functions. What do they do? And we are almost there here. I equals 0, I less than len size I plus plus. After this, yes, what we have to do is char c is get the char from length buffer the ith character and answer plus equals answer. Wait, answer is already there. Answer plus equals length buff no c left shifted by I into 8 times, and again an answer. So that is amazing. And let's also write a function which given an integer writes 4 bytes onto something. Yeah, given an integer writes 4 bytes onto something. No, like which we would be using for our length function, but I guess that is not really good, it seems. Hmm. A function which given for the right part. Yeah, this is fine. This is good enough. They can be used as the return types instead of returning -1. And these two types are recommended way of modern C++ error handling. Ah, that is cool. That is cool. Expected or optional for error handling in C++. Yeah, we can do that. But let's right now I'm just sticking with what they are saying here right now because that would be, I suppose that would be a too much, that would be too much learning new things because this thing is new. This whole socket thing is very, very new. And also C++ and development. This is the first time me doing development in C++. Not technically. I also did some socket programming before, but I don't remember anything. Yeah. So when I'm making an actual deployment project, which I want the world to see, then I will do everything the standard, amazing, cool, expected way. Yep, cool. Assert this, cool, okay. And then the parse function here, 4 plus key max message. The maximum size of the message is this much, this many bytes, okay. Error, no. Error, read full, get full. Okay. Then length. Okay, so we are just reading 4 bytes into a read buffer. That makes sense, which we are also doing the same thing here. Read 4 bytes and then mem copy into length. These 4 bytes assume little endian. Wait, how would mem copy just work? This is little endian, right? So we have to swap the order in which these things are appearing. Little endian. Huh? If our actual, wait, shit, uh, why would this work? We are copying 4 things from this R buffer onto this address. Okay, and how, okay, so we have to see how does mem copy work, because let's say this is our like 4 bytes, which are representing the length 1, 2, 3, 4, and this is in little endian representation. So here is the least significant byte, and here is the most significant byte. And when we are converting this into an integer, we want to switch the order. Integer also uses 4 bytes. We want to switch the order. This least significant byte should go here, like literally here, and most significant one goes here. And shit, they are assuming little endian. Makes sense. They are assuming that the processor is using little endian. So that is why memcopy is working, because they assume that this is little endian. Okay, they assume that this is little endian. Hmm. But yeah, our method is more robust and this would work. Yeah, our method is more robust. So this is better. This is better. We don't have to assume anything, but their assumption is not unreasonable, because most of the modern computers, I guess, suppose, use little endian. Uh, or big endian, like what is used by most computers. Yeah, this is the definition, method, and analogy. Architecture on little endian system appointed to the largest integer 64 bit can be reinterpreted as a pointer to a smaller integer. Yes. Which one to choose? Neither does not really matter. Endianness, understanding big and little endian. Can someone explain to me? Most common, like more common. Little endian is more common, and like in x86 and ARM also it is common. Okay, so that is nice, and so we can assume, but this is also fine. Okay, after this, let's go to the server. Wait, this is the client. Yeah, this is the server. Cannot decompose non-class array type makes sense because parse length does not exist anymore. Okay, what we will do is int len equals uh, what is the name of the function? Parse len. Okay, parse length. and no matching function call to parse length. So parse length does exist. That's it. No matching function call. We have to give in the file descriptor to parse length. C client file descriptor. Okay, we have the length, and if length is -1, then error. Otherwise, we will read this much. But wait, yes, shit. How are they declaring these vectors here? Kmax. Okay, Kmax. That makes sense because we cannot use a variable here. So they are using Kmax. That makes sense. Okay, let's also use Kmax. Max buff equals 4096 2 raised to the power 12. And if we are doing that, we don't even need a string. That is nice. Okay. And now after making sure that client has sent something without any error, what we will do is we will actually read the thing, right? For which we need a character read buffer of size 4, which is the number of bytes used to represent length. Nope, we don't need that. We already have the size. So yeah, cool. Equals empty. Initially everything is empty, and then we will do int n equals read buff read all. But what is the name of the function there? Yeah, that is the name. That is the name. Read all. Read all file descriptor, client file descriptor, and read buffer is this. And how much do we want to read? We want to read length amount of things. And if n is not equal to length, wait, if n is smaller than 0, then error. String just given r1. And this will simply work because everything in this r buffer is initialized to 0. So, and we are going to read smaller than length. And also, shit, we have to make sure after we get the length, assert that length is smaller than equal to, it's smaller than, it cannot be equal because we need one thing, 1 byte for making the string uh, null terminated. So we need 1 byte for that. So this has to be smaller than length. That's nice. After making sure that everything is okay, that is okay. Now we can read a response or like message from a client. We have to write code to write message to the client. And yeah, before we do that, so I'll be right back in a minute. Yeah. And I'm back. And we can begin working on our connections. Okay. One request, one request. Okay, after getting message from the client, we have to write message to the client, and we have a function which will write whatever size we want to write, but we need to append to it the length. Okay, we can use memcopy. Okay, let's first create this memcopy function is pretty cool. Memcopy, we can just copy memory from one place to another, which is cool. Now, what do? We need to write. Yep. I think instead of writing our custom implementation of this endianness function, and this is fine, this is fine, this is fine, what we have written. Now write buffer whose maximum size is 4 plus max buff. Yeah, and yeah, initially everything is 0. Now what we want is we need to create a string and also not just create a string. Yeah, we need to create a string that we are going to write. String is not really something. Char pointer. Shit, we are using C++, so we should not be using char pointer. But anyways, message is going to be say hello from the server. Yeah, hello from the server, and okay, and we'll say size is msg dot size, or shit, sterling. We are totally going C. We are not doing C++ here. We are using native C things. Sterling, sterling, yes, and yep, memcopy, mcpy, yes, memcopy. Uh, Destination, source, and how much. Destination is wbuff plus 4, and source is sz, and how source is msg, and how much size. So the message part is done. Now the buffer part. Now we have to append the length of this thing. Yeah, we have to append the length. We have to append the length. Not append, we have to write down the length in the little endian representation. And we can do it the easy way, and by supposing this thing, the same thing, assuming that our system is using little endian, which is not necessarily true. We don't know. Even though we do know that this system is using little endian, we don't know. We cannot be sure. So let's write a custom function which will do that. Static doesn't return anything. Yep, doesn't return anything. And write length. This takes in an integer x which it has to write, and a char pointer w where it has to write, and in the first 4 bytes this function will write the things in little endian representation. And okay, okay, so for in I equals 0, I is smaller than len size I plus plus in c, or char c equals the last 4 bytes, the last 8 bytes of this integer x. How do we get the last 8 bytes of this integer x into a character? We could take shit. What we could actually do is left shift this whole thing like 3 byte spaces, and then right shift again 3 byte spaces. That would be crazy. That actually is crazy. Left shift this thing 3 byte spaces, not specifically 3, 3 minus I byte spaces. Left shift this thing, and then whatever we get, we have to right shift that whole thing, right shift that whole thing the same amount of times. 3 minus 5. Okay, that is literally crazy. And this thing just means, for example, if we have number, let's say a smaller number, using 3 bits of memory, 4 bits of memory, then what we are doing here, let's say these numbers are 1, 1, 1, 1, right? And we want to get these lower 2 bytes. What we can do is right shift this whole integer x 2 times and then left shift this thing 1 time. So when we right shift, left shift this thing 2 times, we will get 1, 1, 0, 0. These two ones would be gone, and these two ones are the same ones we have here. And these two are like extra zeros. And then we right shift this thing again 2 times and we get 0, 0, 1, 1, which is crazy. And we are essentially getting these lower 2 bits, which is crazy, yeah. And we are doing the same thing here. We get the lower 1 byte from this number integer. And this should be equal to wi equals c. And what we have to do after this is x left shifted by 8. Okay, we have to write 8. We have to we have to also multiply this thing by 8. 8 into 8. Cool. This is actually cool. Okay. Now what do we do? We have written this thing. Now we want to write the size of this whole thing. So write length, where the first thing is the integer that you want to write, which is sz. Sz is the size of this whole message. And where write this at the start of this buffer. Now we can just send this whole thing. Wait, client says before, yeah, yeah, client was speaking there. And now we can write all, file descriptor, client file descriptor. What we have to write this thing, wbuff, and how much is there to write? Size plus 4, size of the message plus the extra 4 bits from the start. We have server-side code, we have server-side code, we have server-side code. Now client-side. Client, after making a connection, client has to write, yeah, the same thing. Literally the same thing. Static, yes, use static const int max buffer size is 4096. We have the maximum buffer size, and after this, yes, let's make a char array, static char array. Right buffer size is max buff plus 4. Well, plus 4, I should write it here. Plus 4, this thing is initially equal to empty. And what is going to be our message? MSG is message is hello there from the server. Uh, Client this side. Okay, we have our message, which is supposed to be a character array. Not this. Yeah, cool. Now we have our message, which we want to mem copy onto our buffer destination. Our source is message, and how much. Let's use size is msg dot, no, it is sterling, yes, sterling of message. Okay, we have to include and size. Okay, we have that, and now we need to write size at the start of this thing. Parts, nope, write length message. The length is size. Where do we want to write it? Onto the buffer. After that, all write all. Yeah, we are not messing up anything, I guess. Yeah, write all. Should we also, we are not taking care of the write all error int n equals this. Maybe we, yeah, we have used n before. So if n smaller than 0, then error return -1. And here, yeah, int n equals write all what, where we want to write. We want to write on this file descriptor socket, and we want to write this buffer. And how much do we want to write? 4 plus size. Redefinition, that is pretty okay. If n is smaller than 0, that would be some error. And why would we return? We won't return. This is the main function. P error, we will print error. Can talk to the server. Cool, cool. Okay. Now we have, the client has written some message onto the server. What we have to do is read whatever the server is trying to convey. Char read buffer size is max buff. Yeah, size is max buff. Initially everything is empty, and we need to now get the length of this message. Length is parse length. I guess that is enough. Okay, yeah. And error checking. If len is smaller than 0, that is some error. Smaller than or equal to 0, that would also be an error. No, equal to 0 is okay. Equal to 0 is okay. That would just mean client is sending a empty string, right? If length is smaller than 0, then the error cannot, wait, talk is a very ambiguous word, like who is doing the talking, cannot send to the server, cannot read to, yeah, from the server, cannot read from the server. Good. And now, yeah, we have the length. We want to call write all. N equals read all from this socket, where read onto the read buffer, and how much read length amount of things. If n smaller than 0, yeah, can't read, cannot read file input lua message from server. Okay, after this, if we were able to read, then print if client says cow say, okay, this thing, and read buff and close the file descriptor. Okay, if this does not work, I will cry. Okay, this thing should be okay. Yeah, this thing should be okay. This thing should be okay. This thing better be okay. G++ server request server. Okay, at least is server is compiling. Client request. Client is compiling. Okay, we will run the client here, and we will run the server here, or we could just run them at the same place. Why? Okay, source dot slash /rc. Huh? Y- yes, source dot /rc. Redis. Missed. Missed. Okay. Clear. Okay. Yes. Dot slash server. Before running, server request. Let's make some change. When the server starts to listen, we will print a message. Server is listening. Okay, cool. Server is listening. We are listening. G++, server, request, server. Okay, compile and then run. Server is listening. Okay. Client. Okay, okay. Working. First try. That is too good. That is like better than it should be. First try, it works. Okay. No, this is okay. Something messed up happened. Hello is gone. HELL is gone. We are reading and there client this side, and here we are reading the whole thing. Hello from the server. This is what client says. I guess we are not reading the thing correctly in the server side. On the server side, we are not reading correctly, and close this panel. Okay, we're not reading correctly. Write all. Read. Read all. Yes, we are messing up on the client side in the mem copy function. When we are writing the message, yep, we are messing up here. This has to be with an offset of 4. Okay, now this should be cool. With plus line requests. Yeah, cool. G++ server client. Okay, and clear. Okay, go to the project. Run the server. Server is running. Run the client. Yo, hello there, client this side, and hello from the server. It is working. It is working. Yeah, cool. That is pretty cool. Nice. 4 missed bytes. Yep. The thing, yeah, like in our whole buffer, that is not a buffer. In our whole buffer that we were sending, uh, I had to start writing the message string from this place and leaving 4 bytes here, which represent the length of the message which is to come after these 4 bytes. But I was writing this message from the start and then overwriting the length over this part, which is not good. And this would lead to some errors, which is, yeah, because this length would say that the message, since the actual real message would lose 4 initial bytes, and the length would represent would say the message is the like this length of the message plus 4 extra bytes. So our server would be reading 4 null bytes, but this would be fine in this case because here before writing, yeah, we are using this thing, and when we use this in C++, whatever is here, it is initialized to its initial value, and for char, the initial normal value is supposed to be 0. So there is no garbage collected value which is there. So this is okay. This was cool. This is cool. Okay. We have our own functions. Okay, how are they doing the writing thing? For reply, okay, this is their reply, constant reply. Okay, client says this thing, and then char buffer 4 size of reply, size of reply. Okay, this has to be constant because size of function also has to be like evaluatable at compile time, because this thing, the size of this thing should be known at compile time. So that is why this is constant. Then we get the length, str length of reply, and yes, we are using strlen, which is crazy. And then mem copy the length and the message. No, shit, this is the length, this is the message. Okay, and write all. Yeah, cool. Error gotchas. Error is set to the error code if the syscall failed. However, error is not set to 0 if the syscall succeeded. It simply keeps the previous value. That is why. Ah, okay, so if we saw an error and then we went on to read some more, do some more networking syscall, this thing is not updated to 0. This would still retain its original value. So where are they changing error no? This thing, error no equals 0. Wait, this is a global variable somewhere. You can also do that. You can also do that. Message, what is message? Message is a function somehow, somewhere. If that is a long name, play as first time, tiny and war. Okay, that seems to be gibberish. After that, bro, you didn't got bored doing this? No, this is pretty cool. And yes, Veritasium says boredom can make you genius, something like that. So yeah, I'm getting genius by being bored. And yep, yeah, this is like manual labor, but this is very pretty worth it. I'm differentiating myself from the crowd. That is what the thing is. Yeah, and yeah, this is just in a way, in my head, this is making me stronger programmers. This is what a good programmer is supposed to do. Okay, Erno is something which we can, but we are not judging if the function like failed or not based on Erno. We have our own values. Well, this is cool. Yeah, we can just return the value returned by read write all. That is nice. That is nice. And what is this message function? Shit, there is an actual variable called message. Shit. Uh, yeah, something called message. You are currently in any company or just learning? I'm just learning right now. I'm in college, 5th semester. Okay, this makes sense. Gotcha. Gotchas. Erno is set to. Yes, we don't have to get into it. Erno or whatever it is. You can read Erno, error number, if Erno, Ehrenjäger, error number, if and only if the call fail. But some libc functions have no way to tell if the call failed other than by clearing error number first. returns 0 on error, but 0 is also a valid result. Okay, I don't get in this part what they are trying to say. Client and testing. Okay, client side. We have done the client side code. Yeah, we did our homework. Erno is a bad old IDNC. We are not using Erno, so that is fine. The Linux kernel doesn't use it at all. Syscalls actually return the error code as a negative integer. It is the syscall wrapper in the libc that puts the error code in Erno. Error number having the error code mixed with the result is still a bad idea. More sensible way is to make a struct, returns the error code, output the result via a pointer. That makes sense. That makes sense. Return the error code 0 or whatever, and read this into this and this much. Actual read. What is actual read? How much was read? That makes sense. How much was read? They mean to say that a number values returned can conflict with a zero with a valid zero return value. Ha. Error number is set to error code if the call failed. Okay, makes sense. However, error number is not set to 0 if syscall succeeded. That also makes sense. It simply keeps the previous value. Makes sense. That is why the above code sets error number to 0 before read full syscall to distinguish the end of file case. That makes sense. That makes sense so that we know before calling this function read full, error number was 0. Like it was okay. Yeah, it was okay. And if it is still okay and we got some error, that would mean end of file. Or if it is not okay, then read error. Okay. And then you can read error number if and only if the call failed. But some can read error number if and only if the call failed. Okay, but some libc functions have no way to tell if the call failed other than by clearing error first. Okay, they were trying to do this thing. Erno failed, returns 0 on error number, but 0 is also a valid result. So we are basically using the same thing to return the result and also to represent error, and that is somehow not good. Like, yes, that is a bad idea, and this is supposed to be the good idea. Return the error number 0 if there is no error, or -1, -2, whatever for the error code. And yeah, read this thing into this buffer and read this much. And this is how much was actually read. Makes sense. And now the client side testing. Okay, I'm already looking at how much is remaining. Yes. Okay, clients and testing. Static int query file descriptor takes in a file descriptor and text creates length. Length cannot be greater than this thing, and this length is the length of the text, null terminated. Okay, and then sending the actual request, write a write buffer, write the length and the message, and see if we were able to write everything. That is good. And then read in their own typical way of reading. Assume little endian, read message too long, otherwise okay. Then reply body, read full. Okay, first we read the length and now we're reading the body. Then do something. Server says this. Yeah. Test our server by sending several commands. Code omitted. Send multiple requests. Yo, this makes sense. This makes sense. We can put all of that reading and writing, communication with the server into some function, call that function repeatedly, and then at the end, done. Go to done. Shit, they are using the go to statements and they are supposed to be bad in some way, which I don't know. Okay. This is the client request, and what we are supposed to do, okay, this whole thing should go in its own thing. Yeah, this thing should go in its own thing, and we will call this query. No, no, we are not going to use the same name. We will call this talk. We don't have n makes sense. 16, yes, what do we return? Whenever there is an error, we can just return -1. Return -1 and do the same thing here. And yeah, do the same thing here. Nope, not -1, but 0. And this message should be given to us from outside powers char pointer msg message. Sure. Yeah, good. And that is nice. Talk to this thing with this message. Create the right buffer, get the length. Yeah, that is cool. That is cool. Now n equals talk to this thing, and first hello from client side. Oh, shit. String literal to char pointer. What are they doing? Shit, you were able to hear that. The like error sound, I guess. This thing expects constant char pointer. And here we just give this the constant. Do we have to add constant there? Is it okay? It is okay somehow. Okay. And if n is smaller than 0, or if n, then we error unable to talk to the server. Like what the hell? Okay. Otherwise, let's do this whole thing again. And yeah, we would like to use go to. After printing, go to end. End does not exist. That is a nice point. It, yeah, this is end. And this is the end. Okay. Okay. The client is cool. The client is cool. Yeah, the client is cool. The client is cool. Recompile and run. Okay. Let's client request dot slash client, and our old server would work. Or maybe not. Assertion field. We said too much. We talked too much, it seems. Okay, the first talk went amazingly, then the second, unable to talk. Yeah, that was the mistake. Unable to talk to the server, connection reset by peer. Unable to talk to the server, connection reset by peer. Okay. Wait, shit, unable to talk to the server, it is something we write here, unable to talk to the server. and it was this thing. Okay, so one of these things gave us an error. Server request dot cpp. So something is not right, completely not right. And it has been 2 hours and 34 minutes. That is nice. Fine. Here something is messed up here. One request. Okay, handle one request. And then in this part, through while through keep handling this one request. If error, then break and close. What are we returning? We should be returning 0, which would not close this thing. And we would go on to handle another request. Yep, we would, but the error was that we are like assert error. And here we are using assert. And this is length is too much. Okay, what is the length? Okay, see how it does not exist. Makes sense. Length f person d new line length plus std out. Yeah, right. Run the server. Okay, go to the folder, run the client. Length is 7725. That is a bit too much. But why is the length this much? We are messing up in our client function somewhere. We are not maybe writing the wait, maybe yeah, we are messing up here somewhere. Let's print f length is %d new line, and here we have the size at flush standard out. C++, compile the client. No, compile the client. Cool. Compile the server. Dot bash server. Run the client. Okay. The second length was just 31, so not really bad. So at least the error is not in interpreting this length. That is nice. Write length on to this buffer. Right size. Okay, maybe we are messing up with this function. Format.cpp, right length, this thing. So x should be something. Uh, this should also work. This should also work. This should also work. Yes, this should also be working. Like this should be working. Printf, let's say. Control C, our character. And we have W0, comma, W1, W2, W2, W3. Printf does not exist. Now it does. Std out or plus standard out. Okay. Now this should be working. And yep. Now this should be working. Client requests. Compile the client. The server is not running anymore. Server. Run the client. Unable to connect to the server. Client says Wait, no, there is also one more mistake. Why do we say that the client is saying something with the server? Okay. Why didn't we see the things which were written? Okay, makes sense, makes sense, makes sense, makes sense. Format server, yes, format. Here, we are using percent %c, but we don't have to use percent %c. What we have to use is hexadecimal value by right. That is what we do. I think this should work now. At least, like, we should be able to see what the client is doing. BBBB. Hmm. That is not very beautiful. That is not very beautiful. We are seeing BBB. How do we interpret this thing? This is actually pretty wrong. This is not the length. The actual length is around 2930. But yeah, certainly not this thing. Yeah. Here, not see out. X printf length is %b, new line. X. Shit, it is printing B because that is what we are printing. Okay, how to print a byte in C. No, not like this, but unsigned integer. Convert my byte into an unsigned integer. We can do that. Or hexadecimal format. This is my char. Use two hexadecimal numbers. Okay. Percent 0 2, that is the precision, and X, capital X. For int I equals 0, I less than 3, 4, I plus plus, I plus plus, and print f percent 0 to capital X, comma WI. And at the end, put char 10, which is a new line. G plus plus, line request, client. Okay, this should work. Hopefully, boot up the server and the client. Like, this should give us some information we can use. Okay, that is nice information. 1E, A, B, C, D, E, F. That is nice. That is like literally amazing. That is amazing. Yes, so our write function is doing amazing. Our write function is doing amazing. It is our server which is reading things in the wrong way. Yep, it is our server which is reading things in the wrong way. And is there some specific pattern to the server, to the mistake the server is making? Server request. Okay, yo. Server request. Yes. Okay. What could be wrong? We are getting the length from this file descriptor. Okay, we might be overlapping. We might be actually overlapping. 4 byte header. Okay. Test our server. We test our server like this. End of file. Client. Understanding read and write. Okay. That is the only thing that is remaining. But What is the error here? Maybe our server is intermangling the things which it is supposed to read and reading things in the wrong way. Okay, let's see what our read function is getting. Parse length. This thing. What is this thing getting? This returns the answer. Length size initially everything is equal to 0 and for int I equals 0, I less than 4, I plus plus. Printf, we will print 0 to hexadecimal characters for length buffer, I character in the length buffer, and here put char 10, 10 means a new line, and after new line we will say flush std out. Yep. And yeah, compile it. We haven't done any change in the server side anyways, just compile again. Run the server, run the client, error. Okay, what do we see? 1.6. Shit, we are calling this function twice. Wait, shit, we are calling this function 3 times. The length is not matching from client side. The length is not matching. The length is not matching. Length is not matching. Here we say that the length of the first message is 30. But here we are seeing that the length is 29. Is it the new line character or like the null terminator? The terminator. The null terminator. This char pointer is null terminated. And this thing +1 for null termination. I think that should fix everything. Not just, yeah, here also, when we are writing stir length +1, because stir length doesn't include that last 0 character, but memcopy does include that. No, no, no. Memcopy only copies how much we want it to copy. Yeah, shit. I messed up. No, no, no. Yes, memcopy only copies how much we want it to copy. Write length this much size 1 1 is 16 and E is 14, 16 plus 14, 30. But on the other side we are not getting 30, we are getting something else, we are getting 29. Yeah, but we are not getting the same things. That is not good. Okay, let's recompile. Client request client backslash server, run the server, run the client here, and there are mistakes. 1E, then a bunch of zeros. There also we see 1E, and here we are seeing 116 and bunch of zeros and 116. And then here we are saying 1F, which is okay, which is just one more than 1E, which is correct for our second string. But here we also get 2E. 2E is causing the error. Yep, 2E is causing the error. 2E is causing the error. Guess, I guess the binary, the hexadecimal number 1F2E would be equal to 717980. So we can do F means 15, 15 into 16 into 16 into 16, 16 square, 256 into 16, 256 into 16, that is a crazy multiplication, into 4, 1204 into 4, 4906, yeah, 4096, plus the second value is F, not 15, 1. So simply just this 1046 plus F, which is 15, 15 into 256, yeah, 256 plus 16 into 2, just 32 plus 14. Okay, shit, I messed up somewhere. This is 13. E, A, B, C, D, E, F. So this should be like 14. Okay, since it is reading one less than the actual answer somehow. Yeah, this is one less than what the actual length is. So there is some error because of that. Why is this reading 29 when here we say 30? That is the whole cause of the error. That is the whole cause of the error. Why are we reading this length as 29 when we are here literally saying something else? Yes, this should not be happening. 29, 29, and let's actually count how many characters are there in the string that you are passing. Okay, from the client side. Okay, first string, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Yes, shit, we are literally not seeing this comma. And what is the ASCII code of this comma? Yes, we have a full stop, which we are not seeing here. The ASCII code of that full stop should be 2E, 2, 32, 32 plus 15. What is 32? 47. ASCII codes. What is the ASCII code for a period, for a dot, single dot? Here, 2E. Shit, it is 2E. That is correct. And we are here seeing 2E because this 2E was not read in the original message. Yeah, so why are we doing this? Why are we doing this? Okay, so we have pinpointed the error. So why is this happening? We are not reading the first message. The server is not reading the first message completely. There is some mistake with this thing. And no, server, let's say, yeah, a server is reading things like this. Yeah, server is reading things like this. Okay, let's compile everything. Okay, server, client, and how is server reading these things? Server is reading this as one six, which is sick. Uh, server is reading this as one E. Okay, and why do we get this server message here? I don't know why we are getting these same messages. Server, why was server printed here? Okay, it was okay, makes sense, makes sense. This was trying to read the things which were sent by the server. That is why makes sense. And the server is reading the first thing as 1E, which is correct. So why is it interpreting 1E as 29? Missing. Why is this thing interpreting 1E as 29? Print f len is no, answer is not being written the correct way. Okay, something is wrong. Read all, read 4 bytes, and these are being read correctly. We are reading 4 bytes. And while I is smaller than this, len buff first. This should kill it. Printf percent 0 to x c. Let's see what c is equal to. Answer plus equals. Shit. Okay. Answer equals 0. Shit. This is the mistake. We are initializing answer as -1, and that is why the length is 1 less than what it is supposed to be. Ah, shit. Okay. 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 And the culprit is right here. My bad. Shit. This was stupid. This was stupid. This was stupid. Now it is correct. Now it is correct. Okay. Now this is correct. And yeah. And let's remove all the bad print statements from everywhere. Here, printf server says, yep, server says something. And okay, yep, we are not using any stupid printf statements anywhere. Here we are. Hello, message. That is nice. That is nice. Do we need something else? Yeah, this thing. Remove this. Client says, and cool. And now compile the server and compile the client, run the server. But before running the server, clear this mess. Run the server. Okay, clear this. Run the client. Boom. We are getting the comma and everything. Client says first hello from client, second hello from client. Yes, so we are over a single connection handling multiple requests. That is cool. That is cool. That is cool. Okay, now that is working. That is cool. We are handling multiple requests on a single connection. That is good. Test your server by sending several commands. Yes, it is working. Yes, it is working. End of file. Let's output end of file whenever we like exit something in server request dot cpp, and here we will say whenever we close a connection, we will say printf connection closed. Yeah, yeah, that is nice. Okay, g++, compile the server, here close, run the server, run the client. Yep, connection closed. Up. Yeah, yeah, yeah. Yep, that is working. That is too good. That is literally too good. Now understanding, read and write, and it has been almost 3 hours. Okay, wait, that was kind of hallucinating, the counting. Wait, yep, it is a stream. Okay, yes, a stream is okay. That is amazing. Now more on protocols, and before that, understanding and read and write. This is like a few paragraphs. We can go through these. Let's see. Why is read full needed? Because you cannot read in one request everything that you want to read. Yeah. Why is read full needed? There are different differences between, yeah, that is like fine. That is fine. Okay, we don't have to read this because I will be reading like, yeah, I don't think I will be able to process more information at this point because we have this thing. I can read this theory to get my theory good. This is amazing. Beats Guide to Network Programming. Brian Beach Johnson Hall. Jorgensen Hall. Yeah, that is nice. And this just came out in 2025, July. That is pretty cool. And version 3. This is version 3 for the book. That is nice. And that would be it for today. What we have done is we have written a request response protocol in our client and our server from both the sides. And let me actually commit this to GitHub. Yes, I do have a GitHub. Git add this thing, git status. There are 3 new files, completely new. Git add, yeah, git commit message added a request response protocol something git push origin master. This should be now on GitHub. So that is nice. And that is pretty cool. Okay, so we did on the server side and the client side how to handle multiple request response protocols with a single connection. So our server will not break the connection unless the client says, I'm done with you. So our server will keep doing the request response protocol handling on its side till the end of time. It will just use a single connection, a single TCP connection for multiple request responses instead of what generally happens. Generally, when we have the client and we have the server, this client sends some request to the server responds, response and requests, and the connection is closed. The connection is closed, but here we think different. So what we have is we have our client and we have our server. They establish a connection, right? And this client sends a request to the server. The server responds with the response, and this cycle just keeps on going. The client keeps on sending requests and the server keeps on responding. And when the client says, nope, I'm good, then then the connection is dropped. Only then the connection gets off. That is it. That is what we did today. So that was nice. And what would be the next thing? Next thing is concurrent IO models. Okay, let's go. We will be using mutexes, I suppose. New thread. Okay, concurrency. This is going to be cool. This is going to be cool. We will be using concurrency. Yeah, that is going to be cool. And that would be the end of today's stream. And thank you for being here. And thank you for being here. This was cool. Thank you.